Hello. How's everybody doing? I heard that the worst time to give a talk is right before lunch. So we're just going to have to power through this one. I have a lot of content, so I'm going to go kind of fast. So pay attention as best you can. And if you miss something, you can just vote for the talk and hear it again later. So it works out for everybody. Although I don't really want to give it twice, but whatever, we'll see. OK, so I'm going to get started. I have some good news and I have some bad news. I actually gave this talk about a year ago. And so the good news is, for a long time, Web Components was primarily a Google effort. And other browsers, vendors expressed interest, but they weren't necessarily actively developing these features. But now, as of some pretty monumental meetings in the spring, Web Components have been adopted, or all browser vendors have agreed to adopt Web Components. And it's a pretty big deal. And I'm making, I guess, some would say a bold prediction, but I think it's a pretty reasonable prediction that Web Components will work natively in all browsers sometime in 2016. So this isn't like some far distant thing that we're all thinking about. I think it's fairly reasonable to make this prediction. So that's the good news. The bad news is when I submitted this talk proposal, Chrome had a native implementation of Web Components, and then these meetings happened where all the browser vendors got together. And in order to reach consensus, the spec changed. And so the problem is right now, as it is today, there's no current implementation of the most recent spec, which means that all of my demos are I have the choice of either they don't work or they're outdated. And so I just decided to go with outdated. So if you want to try them yourself and run them, they will work in Chrome, or they'll work if you use Polymer. But just be aware that some things have changed. Sad face. So I'm just going to briefly go over what's changed. If you don't know what currently exists, just completely ignore this slide. You don't need to know about this stuff. It's going away. So create shadow root has been renamed to attach shadow with a required mode parameter. And I should also mention that I'm talking primarily about Web Components as it's concerned to CSS, not general stuff. Some other things have changed, but these are the things that are related to CSS. So multiple shadow roots have gone away, at least for now. Browser vendors couldn't agree upon how best to do this, and they said, we maybe don't need multiple shadow roots initially, so that's gone away. The content element, which is used for distributing nodes from the main DOM into the shadow DOM, has been renamed from content to slot, which isn't a huge deal, but just something to be aware of. And the content pseudo element has been renamed to slotted, just so you're aware. And also the infamous shadow piercing combinators and pseudo elements have been removed. So you shouldn't have been using them before because they were really bad, and now you can't use them. So that's great. OK, now this is the meat of the talk here. So the question is, why should CSS developers care about Web Components? And I hear people say this. It seems like people seem to think there's this impression that this is a JS thing. Web Components is more for JavaScript components. But I actually think that CSS developers have the most reason to care about Web Components. And to understand why, if you were actually in the last talk, you have a great primer on why I think this. Alex pretty much gave the exact same talk I'm about to give now. So if you were at that one, you can just kind of zone out for a while. But there are a lot of hard problems in CSS. This kind of issue, I think, has been beat to death. There's a lot of great articles written about this. I'm just going to kind of go over some of the obvious ones that we all hopefully know by now. Selectors and class names, all this stuff is global, and everything you write can potentially affect everything else. There's not good ways to scope or isolate a group of CSS rules to a particular DOM element or set of DOM elements. We all know about specificity wars and conflicts and all of that, especially when you have a team with multiple different people writing to the same CSS code base at the same time. All these stuff arise, and it's just really hard to scale as your team gets larger. Unpredictable matching. Alex gave the great example of if you are lazy loading your CSS, and depending upon how the user goes through your site, one component gets loaded before another component, but then if a different user is doing it in the reverse method, then those two rules won't match the same way because the source order is different. And that can be pretty much impossible to deal with in some cases. Managing dependencies. If your style is extending another style, how do you really manage that dependency effectively? And these are all just really hard problems. And then removing unused code. I think it was really funny because Alex gave almost the exact same list in the last talk. I think most people that have thought about these problems have realized that there are all these issues, and how do we deal with them? So what do all of these things have in common? And again, as a little bit of a hint, it's not these things, it's these things. So you don't see the difference. When people first learn CSS, they want to learn properties, and they want to make things look a certain way, and that's all nice. And the longer you work with CSS, the more you realize that selectors are kind of the main issue, the main thing that you have to fight with. They're definitely the biggest determining factor in how scalable your code is. And this is different than almost any other language. In JavaScript or Python or something, you could write a module, and it could be just the worst code ever. And it doesn't really affect the other code. It's isolated. And that's just not true of CSS. The language was not built that way. And it's just really hard to write predictable code when every selector you have potentially affects every other rule that you write. So what are bad selectors? I would argue that really any selector that casts an unnecessarily wide net is a bad selector, because it will increase the chances of unintended matches. It'll just increase the chances of side effects. And in my experience, people who write CSS tend to like doing this. They like living on the edge. They like writing horrible, horrible selectors, just for fun. I don't know why. Here's an example of a selector that I encountered once. So look at it for a second. Let that sink in. This really happened. This was a selector that was written when I started at my previous company that I saw. And this is not an exaggeration. This one single selector caused me to have to do 1 month's extra work to get around it. It was just impossible. I mean, there was this particular layout where it just so happened that the divs that were inside of divs that were inside of divs were all 2 columns. And so this rule made sense to somebody. And what are the chances that you're going to add another div to a page? Pretty low, right? So, and you might be thinking, okay, but my selectors aren't that bad. I go to CSS Dev Conf. I'm smart about CSS. I write better selectors. And it's probably not true, actually, because everyone writes horrible selectors, me included. It's just the nature of these things. But you might be using a naming convention. You might be using a linter. You might be using some kind of tool or something that checks for this stuff to make sure that you're only targeting classes, or that your specificity is low, and all of the kind of best practices. But even that kind of has problems. And this is another example I want to use. This example is from Bootstrap. And I'm not trying to be Bootstrap bashing here. Estelle says go for it. I'm not trying to be Bootstrap bashing, but I'm about to do it. So I remember the first time I saw this. So let's just walk through these class names for a second. I think it'll be a fun experience that we can all do together, right? So it starts out with a navbar, and then navbar default. So I'm following it at this point. You have a navbar, and you have a state of the navbar, and it's the state of default. Inside of that, you have a container. Okay, we've all used containers. Sometimes in CSS, you need to add a div to bake things in a certain place, and that's what a container is for. And it's fluid in this case. Again, it makes perfect sense. Now there's another container inside of that. I'm not entirely sure why it needs 2, but maybe it does. I trust that this is a very well-tested library, possibly one of the most well-tested libraries on the planet. And so this container has this collapse, and it has this navbar collapse. I don't really know what the difference is. And then below that, we have nav, and then navbar nav. And I don't know why all of these navs need to be there. And so at this point, I'm completely lost. And I don't use Bootstrap, so I don't really know what this is doing. But my main question is, what are all these classes, and why do I need them? And if I remove one, is it going to break? Is it not going to break? I'm not really sure. And so I have a word for this kind of thing, and the word is implementation details. And Alex mentioned this in his previous talk, and I think that's a great point, that when you are creating components and you are providing them for use by third-party developers, it kind of sucks that in CSS we have to have all of these implementation details. These 8 classes have to be added in this exact DOM structure in order for your navbar to work the way you want it to work. And there's so much potential for misuse with that. So what's the answer? If selectors that depend on markup is bad, and if markup full of implementation details is bad, how should we be writing CSS? So I would argue that the problem isn't that our CSS is bad. The problem is that our CSS is operating on far too much DOM. It's really an impossible ask for us to be able to write selectors that affect an entire app, and they all operate in this global space, and they all just work. It's just not, it's not feasible. It's too much to ask. It's something that I don't think the original creators of CSS realized would happen. So I think the real question isn't how do I write good CSS. The real question is how should we change CSS to make it harder to screw up? Because a lot of other languages do this. They make it hard for you to screw up. They have modules that are encapsulated, and variables don't leak out into other things. And this is just kind of normal in most languages. In CSS, it doesn't exist. So when I think about what is CSS missing, or what could I change about it to solve some of these problems, I'm just kind of like a brief list that just came to me. You know, as I mentioned, the ability to scope or isolate styles to a particular set of DOM nodes. The ability to abstract away the implementation details so that consumers of your component don't have to know all of this stuff. The ability to bundle a set of styles with the markup and logic that depends upon them. I mean, how often have you wanted to use like a select to widget, but then you had to go get the JavaScript file. Oh, and you also had to get the CSS file. Oh, and you also had to get all of the images that the CSS file references. I mean, that's kind of a pain, and it's just hard to manage. And it would be nice if you could bundle all that stuff together. So what's pretty awesome is that it turns out that Web Components actually does all of this for us. So some people out there say, but hold on, why should we change CSS? Aren't these problems already solved by React, or inline styles, or CSS modules, or one of the million acronyms for CSS naming conventions that all attempt to solve these problems? And so I say the answer to that is no, but like, okay, maybe a little bit. Because I think it's true. Like, I've used every single one of those things that I just listed, and I think they're all great. I think they're all good attempts to address the problem with current technology. But there are some key differences between those situations and web components. I really don't like when I see people arguing on Twitter about React versus web components, because it's apples and oranges. These are not the same things. And some of the differences are that all of the things that I just showed, they leverage tools and conventions to address the problem, which is nice. There's nothing wrong with tools and conventions. But they raise the barrier to entry for new developers. They make everything a little bit more complicated. I mean, if you were writing web applications or websites 10 years ago, everything just felt a little bit like easier to get started. You just open up Notepad or something and you put some content on there, and it just kind of worked. And these days, there's so much that stuff you have to learn to get into it. Adding more things just to solve these CSS problems that should be solved in the platform I think it's kind of a big ask. And all of these tools, they really only address the symptoms. They don't address the underlying cause, because they can't really. That would take an actual change in the platform. And the benefits of a platform-based solution are kind of the opposite of what I just said. No extra knowledge is required. If you could write CSS 5 or 10 years ago, you can write it today with web components. I should give the caveat that it's obviously if you want to author web components, you have to learn how web components work. But if you're just consuming them, there's no extra information that you have to learn. It all works exactly the same way. There's no framework or library or build tool dependencies. And then arguably the biggest win for web components in my mind is interoperability. I'm sure everyone here at some point used a jQuery plugin, and then you decided to build an Angular app, and you had to find the Angular equivalent of that jQuery plugin. I mean, there are people that they spend all their day just converting a plugin from one ecosystem into a plugin in a different ecosystem. And there's no reason that we should be doing this. It doesn't make sense. It's not scalable. It's a waste of time. With web components, because they are just native HTML components, it works regardless of the framework you're using, and it works regardless of any of these other considerations. It works the same way that you could use a div or a span. It doesn't matter. OK, so you guys sold yet? Yes? No? OK, let's hope so. All right, let's dive in. So I'm going to give a brief overview of the anatomy of a web component. If you already know this, I hate how every web component's talk has to explain what web components are, but they kind of do. So I'll just do that real quick. Web components itself is not a specification. It consists of 4 new technologies, new-ish. They've been around for a couple of years now, but those are Shadow DOM, custom elements, HTML imports, and the template element. So Shadow DOM is a subtree of DOM nodes that you can create on any HTML element. And I want to kind of dispel a myth here. You don't need to use custom elements to use Shadow DOM. You don't need to use imports to use Shadow DOM or template to use Shadow DOM. You can use Shadow DOM right now on any element. I mean, assuming the browser supports it, but you don't need these other things. When you're using it with the main DOM, the main DOM gets merged into the shadow DOM, and they combine to form like the composed rendered tree. But the great thing about shadow DOM is that the CSS that you write in the main DOM does not touch the CSS in the shadow DOM. And I'm going to give an example of that. So like shadow nodes are private in the same way that if you've written classes in other languages that have private and public methods, think about shadow nodes as being the private methods and the main DOM nodes as being the public methods. All right, so here's some code. Here's a simple example of how you could use shadow DOM today. So the very first couple lines up here, we create a p element and we add it to the body. And then you just call create shadow root. And remember, that's now called attach shadow, but don't worry about it. We're going to call create shadow root. And then you get this shadow root property on the p element, and you set its inner HTML to just a string of HTML text, and that's all there is. So let's go do a demo here, live coding. OK, so this is a paragraph with some fancy text inside of it. And if you look at this fancy text thing here, you can see that it's got the class fancy, and it has the color red, and the font family fantasy. OK, great. So let's store a reference to that, call it p1, and we'll do a query selector, for p. All right, so that's our p1. Now we're going to create a new element. Can't type today. We're going to create a new element. We're going to store it on p2, and then we're going to add it to the body. p2. All right, so now you see that there's just empty p element here. OK, so now we're going to call create shadow root on p2. And now if you look at it, there is this shadow root inside of the element. So there's a shadow root property, and we can just set inner HTML. And let's just set the inner HTML to be the same as the inner HTML of the first paragraph. So then we have two paragraphs with the exact same HTML. OK, so what you should immediately notice is that this fancy text in here is not actually styled like fancy text above. And this is actually pretty amazing if you've ever written CSS and had this problem. Like this ability to not have the outside CSS affect this is really cool. So if we look at fancy text, it's still got that class fancy. And if we check these styles, none of them apply. Well, let's say we wanted to style fancy text differently. So we could go back to our shadow DOM, and we could add, I don't know, a style tag. And let's say fancy. Somebody shout out a CSS color. Way to pick a color almost the same as the other color. But as you can see, the tomato color is not affecting the fancy text. Trust me, it's not. I know it looks the same. But it's not affecting the fancy text from the first paragraph, and vice versa. So these styles really are encapsulated. They do not affect each other. And this is working natively here in Chrome right now. So custom elements. Custom elements are kind of one of the core things you think about when you think about web components. And they are essentially a JavaScript class that gets identified with a DOM tag name. So just to kind of show an example, like let's select this heading up here. So this heading is custom elements. And if we look at what the constructor is, you'll probably notice, if you can read that it says HTML heading element. And it gets associated with that H2, the tag name. And we could even look and see what its kind of parent class is, and that's the HTML element. And so all HTML elements inherit from this HTML element class in JavaScript. And so when you create a custom element, you do the same thing. You create a new class that inherits from HTML element, and then you register it on the document with a particular tag name. And then these things have lifecycle methods. Like if you're familiar with React, it's kind of a similar idea where at different points in the element's life, certain callbacks are added. And in the created callback, that's where you create the shadow DOM and do all of the things that you do. So here's a simple example of that. Let's say we want to you can't have a good CSS talk without talking about the media object. So let's have the media object element that extends HTML element. And then in our created callback, we are going to establish the shadow root, and we're just going to set the shadow root to have some context, just like I did in the previous example. And then we're going to register that element on the document, and we're going to call it media object, and then we're going to say the media object tag is associated with this class. So the last two things, HTML imports and HTML templates, I'll go over pretty quickly. Imports, I mentioned this before, is kind of just like a way of bundling a bunch of different things together as a single file. If you want to bundle JavaScript and CSS and other HTML files and other component dependencies, you can kind of package all that stuff up into a single element so the consumers of your module only have to import one thing. And you no longer need to manage all this stuff separately. You no longer have to say, oh, like add this JavaScript, but make sure to add it at the end of the body, and then you add the CSS, but make sure to add it at the beginning of the head. Like all of that stuff goes away. You just have imports. And yes, other custom elements will also import their own dependencies using these imports. And templates are pretty trivial, but they're pretty cool. They're basically inert bits of DOM, and by inert I mean the browser doesn't parse them. So today, if you added a DOM node with a style tag in it, that style would apply everywhere. If you have a template element, you can put a style tag in the template element, and the browser doesn't consider it. And this is great if you want to have something that you would then clone and then apply later. But at the beginning, you can add it to your page, and it doesn't affect things in your page. And templates are most normally used to create shadow DOM from. So here's an example of a full component that uses kind of all of these things. We're going to call it like super element. So this import is in super element.html. It has a dependency called dependent element that we're importing up at the top with the link tag. We're defining a template element that uses the dependent element, and then we would have some shadow DOM styles in here. And then we create our super element constructor that extends HTML element. And then here we query selector for the template and set its inner HTML to be the inner HTML of the shadow root. So there's a lot of code. Sorry to glaze over it, but the slides are posted online. So if you want to download this and run it, you can. And a lot of the examples that I'm going to have here, you can just run in your browser really easily, and you can run it from the online posted version of the slides. So I don't know what's going on here. Uh-oh, I don't want to print. I guess the size is messed up here. OK. So another question is, how does Shadow DOM interact with the main DOM? And this is one of the awesome parts about Shadow DOM. You have these things called insertion points in your Shadow DOM, because if you think about, let's say that we have that media object thing here, and inside of a media object, you'll typically have an image that's on the left, and then you have content that's on the right. If you're not familiar with a media object, that's kind of what it is. It's a basic two-column element with some kind of image on the right or on the left, and then content on the right. So how do these things that are inside of it get used ultimately? So in the Shadow DOM, you can define insertion points that use this content tag. And remember, it's called slot now. OK. So the content tag, you can then pass in a CSS selector to select what type of content gets inserted at that particular point. And so in this case, I'm saying image. And then you can have a content tag with no select, which just gets everything else. So the way that this ends up finally looking, I don't know if you can see. Is that gray too gray or too light? OK. So this is what the final composed tree would look like. And the grayed out nodes are the Shadow DOM nodes. And then the regular blue ones are the light DOM. So it all gets kind of mashed together in the final produced output, that it's what the browser sees, and it's what screen readers see, and it's what all this stuff sees. And so it's all there. It's just that your styling doesn't affect the shadow nodes. So now that we kind of know a little about what components are, let's talk about how you write modular CSS in a Shadow DOM world. How can we take the best practices that we know of today and transfer them into kind of this web components paradigm? And it's really impossible to talk about modularity and code reuse in software development without talking about the two principles of inheritance and composition. So these things, one of the easiest ways to explain these concepts is with ISA and HASA relationships. Inheritance establishes an ISA relationship, and composition establishes a HASA relationship. For example, a Toyota is a car, and a Toyota has a steering wheel. So in the first case, Toyota inherits from car, and in the second case, Toyota composes steering wheel into it. That's a brief overview. So in OOCSS, you might see something like this, where let's say we have a media object and we want to extend it to create a profile card. You would see something like these two classes, where you add the media object base class, and then the profile card class adds the additional rules that you need to style the media object differently to become a profile card. In Sass, you might see something like this, where you use the addExtend keyword so that you only have to use the profile card class. So what would this look like in a web component world? So typically, in web components, if you want to extend a class or a component, you'll import the base component. You'll call the base component's created callback, which then creates the shadow root from the parent component. And then you add to that shadow root, like I did in that first example, the additional styles. Now this might seem like way more complicated than the previous example where you just added a second class to it. I'm showing kind of how this works with vanilla web components, but most likely, if you are using web components, a year from now, libraries will make all of this really easy. You can just say, oh, this thing extends this other thing, and it will all work. But this is kind of how it works under the hood. And so here's a case where you have a profile card that extends media object. So I'm importing media object at the top. I'm defining my additional styles here in the template. And then I'm creating the profile card element, and I'm extending media object element instead of HTML element to keep the chain going. And then I have my created callback where I call super to get the media object shadow DOM. And then I add to the shadow root by cloning the template and adding its inner HTML. So sorry if that's a lot of code, but I'll have some pictures here to make it all make sense. So this is an example of a media object. This is actually using web components right now. It's running on my browser. If we look inside, we can see you can see that here we have the shadow root with the figure and the div, as I showed before. If we look in the style thing, we can see sorry, let's just make this a little bit easier to read. You'll see that there's a style tag in the figure and the div, and the style has the styles for the media object itself. Note that there's 3 children here, and there's 1 style attribute. So this is the profile card. So as you can see when you look at it, it clearly is a media object, but it's a media object that's been extended with some more styles and some more interesting stuff. And again, if we look at what's going on here, and if we look in the shadow root, you can see that there's this style tag, which is the media object styles, and then there's this additional style that we added, and these are the profile card styles that have been added to that. And again, if this seems like overly complicated to do extension, the nice thing about, keep in mind that I think libraries will handle this in the future, but the nice thing about this is because all of this stuff gets encapsulated into the shadow DOM of the component, there's no leaking out, there's no leaking in, and you can also control the order in which these things are applied. One thing that you can't do in CSS today, like let's say component C depends on A and B, and component D depends on A and B, but depends on A and B in the reverse order. That's impossible to do today in CSS, because everything is global, and if you change the order, you have to change it globally. Well, with Shadow DOM, you could change the order of dependencies, and there would be like no problem at all with that. So let's move into composition. Composition, like I mentioned, has the has-a relationship. Here's an example that you might see today using BEM syntax of, let's say, a catalog. And we have a catalog, and we have catalog items. And these items, maybe we want to lay them out as a grid. So we're going to have a grid container, and then the grid container is going to have some grid cell items, and then inside of that, we have the catalog item. And so in this case, the catalog is composing the grid to make the final component. But again, this is a lot of implementation detail, and that means anyone that wants to use the catalog has to know that you have to use the grid to make this work. And this is kind of unreasonable to always expect people to have to know this. You have to then create style guides, and you have to have all of this instruction, and it's harder than it needs to be. So with web components, you could do this much more simply. When you compose stuff, you typically will import the components that you're composing, and then you just use them in your Shadow DOM. And typically, when you're composing things, you take simple elements and you build more complex elements with them. It's the kind of classic Lego blocks analogy here. To kind of go over what a base element might be, the media object that I just used could be an example of a base object. Typically, though, base objects are things where you define primitives like layout and positioning, and then leave ornamentation like colors and borders and shadows and all of that stuff to the extending or the composing element. So here's an example of some kind of base layout elements that I have. The first one is a Flexgrid. So Flexgrid, you just have the Flexgrid element, and then you just have any children that you want inside of it. So let's go ahead and unmaximize this. OK, so if you notice Flexgrid, the nice thing about it is it's flexible. And as I resize, it kind of automatically fills the space, but wraps to the next line with like kind of what you would do with like a multi-line Flexbox grid example. You know, it's presentational, but it's nice and it kind of does its thing. And this is an example of a base component. You're not just going to use this as it is, but you would use it to lay out other components. The FlexLine demo is similar, but if we look back here at what FlexLine does, it allows any arbitrary children, and then you can optionally put a flex attribute on those children to make them flex to fill the remaining space, like you would with Flexbox. You could use FlexLine, and you could specify a column to make the column. Sorry, to make it like a flex direction column Flexbox container as opposed to the row. And so here's like a complex example of, you know, this has, the first one is a column that's got four Flexbox items. And then in the middle, you have two Flexbox rows that go, you know, with the sidebar, content sidebar, and then like this add section. And so this is like nicely flexible and, you know, and responsive and everything. So you might be thinking to yourself, though, FlexLine and FlexGrid are very presentational elements. Maybe you have more of a pure spent and you do not want this presentational stuff in your markup. Well, the great thing about Shadow DOM is you don't have to do that. So I'm going to show you an example of building a Holy Grail type layout that composes FlexLine, but composes it in a Shadow DOM so you don't have to worry about the implementation details. So on the left here is the example of Holy Grail, and then you have your header, you have your main content area, you have your navigation, which is going to go on the left. You have your aside, which maybe has some advertisements, go on the right. And then you have your footer. And then here's the Shadow DOM that you would use for that. And notice how we have like FlexLine components. We have like random div container components. All of these implementation details that are required to make this thing lay out the way we need to with Flexbox. But there are things that you shouldn't have to worry about. And then we have our insertion points where the content is selecting the various elements that go inside. And so this is what the composed. Actually, let's do the demo first. So here's the demo. And if you look at the source, you can see it's literally just this, what I just showed you. You know, we've imported the Holy Grail using a link rel import, and then we use it, and we just add these HTML tags on the inside. And because our Shadow DOM said that we could use those specific tags and it knew what to do with them, then we get, you know, this nice Holy Grail layout without having to worry about how it works, and without having to worry about whether our external styles are going to conflict with it, or without having to worry about these styles leaking out and conflicting with other things. And so this is what the final composed tree looks like in the Shadow DOM. You can see everything in gray here is the shadow nodes, and everything in blue is the regular nodes. So one more example I have is kind of showing like a lot of these things combined together, because most of what we do when we build apps is we have all of these primitives and we put them all together to kind of build like a full site or full application. And so let's like go over an example of building a profile card gallery that uses the profile card, which we've already said inherits from media object. So that's an example of inheritance. And then we have this FlexGrid element, which we're going to compose in the profile card gallery. So here's what we want our DOM to look like. We want to be able to say we're using this profile card gallery element, and we just want to pass some profile cards inside of it. And we want it to know what to do with that. In the Shadow DOM, we're using a FlexGrid, and then we're saying with our content element that we only want to select profile cards. So that if you throw in some other child element into this, like some other divs or some other random stuff, it's not going to do anything with those. And then let's make this smaller. So here's an example of this working, and you can see it's the same properties of this Flexgrid, but it's got these profile cards inside of them, as opposed to just the empty divs before. And again, if we look at the source, you can see it really is just this profile card gallery element, and then profile cards inside of it. And not to repeat myself here too much, but keep in mind that these styles don't leak in or out. You don't have to worry that the styles where you define in this profile card gallery, they're not going to affect anything else, and nothing on the outside is going to get in. So you can create these components that you can put on GitHub, and you can be confident that somebody else could download them and use them in their app, and there would be no chance that the external styles would get in and affect the way that your component looks, unless you make it, unless you add hooks to make that happen. It's all opt-in. And so this is what the final compose tree would look like. You have your profile card gallery root, and then you have this Flexgrid that's hosting these profile cards. And I'm using the square bracket syntax just to mean that these profile cards are inheriting from media object. So you might be thinking, OK, well, if nothing gets in through the shadow DOM, how do we style these third-party components? So a couple of the other talks already addressed on this a little bit. But the answer to this is CSS Custom Properties. So if you're unfamiliar with custom properties, think of them like any other property. I mean, imagine if any other inheritable property. Imagine if you define the font color on body to be red. You would expect all of the text on the page to be red, because child elements of body inherit that property. Some properties, like border, are not inherited. So think of it as like these inheritable properties. So the way that Shadow DOM works by default is inheritable properties actually do go in through the Shadow DOM. And this kind of makes sense, because if you have a component that you want somebody to use on their site, you want your font family to match the font family that they're using. And so you want that to inherit through. And let's say that you don't want it to inherit through. You can always stop that from happening by using the all CSS keyword and just saying all initial or all unset. And then you get no inheritance. So you have all of the control as the component author, what gets in and what gets out. So you may have noticed in that Flexgrid example, the gutter was a little bit different than the other example. Or maybe you didn't notice the difference between 1M and 1.5M on this screen. But it was a little bit different, and the Flexgrid basis was also a little bit different. If we go back to the code here for this profile card gallery, I was setting in the style tag in my shadow DOM on Flexgrid these properties. And so if I went to change this to maybe let's say 5M as the gutter, and then we go back to the demo. I don't know if you can. There we go. So anyway, so that's one example of how you would do that. You would just change that CSS property, and then you can make the gutter bigger, and that's how you can expose that to end users. All right. And these, I mentioned the shadow piercing combinators before. These things are replacing those. This is kind of now the new kind of de facto way of styling web components. And you no longer have this kind of arbitrary way to extend into the shadow DOM, which offers more protection to the component authors. You don't have to worry about people messing with your stuff. In some cases, you might imagine yourself, oh, I have all of these properties I want to expose. I don't want to have a million different properties that I don't want to have to say like Flexgrid border, Flexgrid background, Flexgrid color, you don't want to do that. And so there's this new proposal for this @apply rule that you can pass in. It's like a mix-ins in Sass. You can pass in kind of an arbitrary, what's called like a bag of properties. And so in this case, I'm defining this custom property Flexgrid styles. Uh-oh, Xcode failed to download. It's going to come to bite me later. So you can define Flexgrid styles, and then you can just pass in these arbitrary properties. Like in this case, I'm doing border and margin, and then you can apply them in the shadow DOM. And because this property inherits, the component author can say, OK, I'm going to give users of my component the ability to pass in whatever properties they want on this custom property name. And that's how you can use that to kind of give more control if you want people to have more control over styling your custom elements. A third way, which is not on a standards track as of yet, but from my discussions with people who have been going to these meetings, it seems like everyone kind of wants custom pseudo elements to exist also as an additional way of styling third-party web components. And what that looks like would be we use this part attribute. And so let's say that I'm creating a date picker or date range picker component. It's going to have a start date and an end date. And I could then say I want to define the attribute part and say start date here. And I want to define this one to be end date. And then in the shadow DOM, or sorry, this would be in your shadow DOM. And then in your main CSS, you could use the pseudo element part and pass it the name of the pseudo element. And then you could use that to style. And this works really well, actually, in cases where, like, let's say, in the same way that in the React inline styles talk, like hover states and enabled or focused, like those things don't work really well as an object because you need a selector for that. The custom property bag that you can apply doesn't work really well for those states either. If you want to set something to a certain hover rule, but only when it's active and when it's enabled, the way to do that today, you would have to have a different variable for all of those possible combinations, which is kind of unreasonable. And so custom pseudo elements are a solution to that problem, where you basically expose the whole element to the main DOM for styling purposes. OK, so I've covered a lot here, so I want to kind of go over some things. Writing scalable CSS today is challenging because all rules are global, and they can conflict with other rules in unexpected ways, and you have all of these side effects. And managing the global nature of CSS at scale, it usually involves, I mean, if you're following kind of today's best practices, it usually involves just littering your HTML with all of these classes and all of this stuff, which is essentially just implementation details that people shouldn't have to worry about. And you can abstract away the implementation details through templating or through build systems or through helper functions. But all of that stuff raises the barrier to entry for new developers, and it's app specific, and it's just complicated. And these are things that really should be addressed at the platform. And web components do address all of these problems, and they do so at the platform level. And again, the barrier to entry remains pretty low. I think web components will change how we think about modularizing our CSS. I mean, a lot of the principles are consistent, but I think the implementation of those will change. I mean, these verbose naming systems that I am a big advocate of today, because that's what we need now, but they're going to go away because we won't really need to use them. We can use selectors. We can use really what I would consider to be horrible selectors today in our shadow DOM, and it won't be a problem because if your shadow DOM only has 4 elements, it's not like complicated to see how that selector would work. There's no risk of that accidentally applying to somebody else's element. CSS files will become smaller and they'll become self-contained. You won't be having all of these like Sass partials that then just get built into this massive style sheet. You'll have individual CSS files that you'll include into your shadow DOM as you need them. And they do one thing, like any good module system, those things do one thing and they do one thing only, and they do it well. And again, complex components will be built and styled by composing and extending existing components with their existing styles. And third-party component theming, today, if you want to, again, to use the select to example, if you wanted to change the way select to looks, you'd have to go in and override every single one of those select to style rules. And it's really messy, and if they change their styles, then now you have to redo that whole thing. And so component theming will be much better in the future because people will expose these custom properties that you could use. So I really want to emphasize this. Web components, they're definitely happening. If you've heard some people talking about, oh, this is going to happen, this is not going to happen, it's definitely happening, and it's happening soon. You can already use almost everything in web components with the web components.js polyfills. This is what Polymer uses. The only one that doesn't really work well is Shadow DOM because it kind of requires the browser to understand what's going on. It's really almost impossible to polyfill that. But Shadow DOM is going to be available. And like I said at the beginning, I'm going to, I'll stand here today, and you can quote me on this. I'm going to make the prediction that Shadow DOM will be available in all major browsers. That's Chrome, Firefox, Safari, Opera, and Edge 1 year from today. And I'm going to predict it will be the day that Safari 10 gets released, just because. So you can use the hashtag ShadowDOM 2016 to show your support in the 2016 election for Shadow DOM. And in terms of preparing for this future now, if you're already using something like inline styles, if you're already using something like CSS modules, if you're already using BEM, or any kind of object-oriented way of thinking about your styles, you're in pretty good shape. It'll just be a matter of kind of using it in the web component variant in the future. And the great thing about that story is it's not an all or nothing thing. Like, you don't have to just redo your entire app in web components. You can do it one at a time, piecemeal. It doesn't really matter. They're not going to. It's not this entire paradigm shift. It can be done kind of in this incremental basis. Yeah, again, just to reiterate, I definitely can't, more strongly recommend thinking about it in terms of the component designs now. Like, start using, if you're not already using things like BEM or SMAX or OCSS, it'll make the transition, much better. And kind of as a final thought, I think you hear a lot of great things about web components, but you also hear some naysayers. And I guess all I have to say to the naysayers is, like, the web platform has a lot of crappy things about it, and those crappy things are going to be there forever. And if you want to continue to use the crappy parts of it forever, you can totally do that. Nobody's stopping you from doing that. Just because web components is a thing that's being implemented in browsers doesn't mean that you have to use it. If it makes your life easier, you should definitely use it. And if it's going to make your life harder, then you should definitely not use it and find another solution. Just speaking personally, I can't wait until we're in a world where web components, ES6 modules, and then HTTP2 is fully supported everywhere. And then we can have these kind of small, reusable files that we don't have to worry about concatenating everything together. We don't have to worry about all of these kind of current best practices, and all of that stuff goes away. It's definitely an exciting time, I think, to be doing web development. I think the future is bright. And that's it. Yeah, so I know that I want to do questions if people have questions, but if you wanted to vote for this session, here's an example text that you could send to this phone number. So.